Number 4 starts with the function f of x equals e to the x minus 1, all divided by x squared. Part A wants us to find the derivative. Definitely need to start with the quotient rule. Make sure you use good notation on the exam, meaning f prime of x equals. Okay, so the bottom is going to get squared. We'll do that first. And then the quotient rule says bottom times derivative of the top minus the top times the derivative of the bottom. So the only thing missing here is the derivative of the top. So the derivative of e to the x is just itself, and the derivative of minus x is minus 1, and the derivative of any constant is 0. So this is the derivative. It's fine if I say on the exam, don't simplify your answer. It's fine to leave it like that, but let's just go ahead and do a little bit of simplifying here. We'll distribute to get rid of the parentheses. Actually, yeah, we'll go ahead and do that. And then see if we have any like terms. So I guess we have a minus x squared and a 2x squared. So we'll mush them together. And I think those are the only like terms here. And then finally, if you can factor anything out, you should. And I guess we can factor x out of everything on top. And now that it's factored, we're ready to cancel. One of these x's goes away, and this x goes away. So there's our final answer. Part B wants us to find the limit as x goes to 0 of f of x. So let's see. The first thing we do is plug in. Instead of x, we're going to put 0. So this would be like an e to the 0 minus 1 over 0 squared. Okay, so the bottom is 0. E to the 0 is 1 minus 1 is 0 over 0. So what do you do when you see 0 over 0? You use L'Hopital's rule. So let's try that down below. This will be part B down here. Okay, so by L'Hopital's rule, because we have one of the indeterminate forms, that 0 over 0, we get to take the derivative of the top and the bottom separately, not the quotient rule. So the derivative upstairs is e to the x minus 1. Downstairs is 2x. Again, not the quotient rule. And then we see a new limit. So we plug in top and bottom, 0 for both x's. So if you plug 0 in the top for the x, I think you'll see you get 0 altogether. And on the bottom, you also get 0. So we'll do L'Hopital's rule one more time, which means take a derivative upstairs. That's e to the x. Downstairs is 2. And then when we plug in 0 here, we just get a half, which is our answer. So this one required L'Hopital's rule twice. And then finally, part C, limit as x goes to infinity of f of x. Okay, so it feels like we can kind of hand wave here and say that we know that, that e to the x dominates. So whatever this thing wants to do, that's what's going to happen. So I feel like the answer is going to be infinity, but let's go ahead and use L'Hopital's rule anyway. So we plug in infinity on the top and the bottom. And on the top, we get a really big infinity minus a kind of little infinity minus 1. So I feel like the top is infinity divided by, and then we have infinity squared. And so we've got infinity over infinity, which is one of our acceptable indeterminate forms, which means we can use L'Hopital's rule again. Oh, this should have been infinity here. Okay, derivative upstairs, e to the x minus 1, downstairs 2x. We'll plug in infinity. I think we'll see infinity over infinity again. So we'll do L'Hopital's one more time. Of course, we'll get the same thing we got before, e to the x over 2. You see that up here. And now when we plug in infinity, we get something really huge on top over 2, which is infinity. So our intuition was right. E to the x eventually dominates, and this whole function goes to infinity.